Good afternoon, everyone. I'm Daniele Ghedalia, sales engineer at Optotune, and I'm very pleased to tell you a bit more about liquid lenses, which problems we solve, how they work, and also provide an overview about real use cases where customers benefit from our technology. So that's the problem that we solve. Usually fixed focus optics, traditional fixed focus optics have a working distance range which is limited by the depth of field, meaning that you can only focus at a specific working distance. And the usual ways that this problem can be addressed is either to reduce the F number of your optical system, and this will work, but it will limit the amount of light that reaches the sensor, and maybe you can reach the diffraction limit and lose resolution. Or you can rely on traditional focusing mechanisms, which might be too bulky or too slow or too, let's say, energy hungry. Or you can even think about introducing more cameras and lenses in your system, which might be not economical or also a bit difficult to integrate. And some real use cases about how this problem presents itself can happen, for example, in logistics or barcode reading, where, as you can see, on the same conveyor belt, you might have packages which are higher and some which are smaller. And as a consequence, the working distance will be different. And at a given point in time, you can only focus on a specific surface, and maybe you cannot be fast enough to quickly adjust focus so that you can read the barcode on the next package. Another real example of how this problem can present difficulties and challenges is in high magnification inspection of electronics or bond inspection, where the depth of field is usually very shallow due to the high magnification. And as you can see here, we can see that where the wires are bonded, we can be nicely in focus, but in the background or on the rest of the PCB, we are a bit blurry. And the focus tunable lens or liquid lens technology enables to address these challenges and to solve them by basically increasing the working distance range in a few milliseconds without any mechanically moving element. As you can see, you can keep the F number low and the depth of field shallow, but in a few milliseconds, you can basically refocus over a large working distance range. And I will explain in the next slide how this works. But on a concrete level, as you can see on this animated GIF, you can see that Cognex has successfully integrated liquid lenses from us in their barcode readers in a way that in a few milliseconds, no matter how tall the pallet or package is, you can quickly and nicely refocus so that the barcode is resolved and read successfully. And similarly, in applications such as semiconductor inspection or electronics inspection, you can basically keep the shallow depth of field that gives you the nice resolution you need. And you can even achieve an all-in-focus 3D stack with a super shallow depth of field. So you can basically reconstruct the whole 3D, let's say, image of an electronic component. So basically both situations, so more of a wide angle field of view as well as a telecentric situation can be addressed using our focus tunable lenses. So after giving you some flavor or taste about which problems we solve, I would like to explain on a high level how does the liquid lens actually work. So the core of our technology relies on a container, which basically contains a special optical liquid developed by us, which is encapsulated by a thin elastic membrane. And basically using the Lorentz force, which some of you might have studied at school, basically the interaction of an electrical current with a magnetic field, which is generated by a permanent magnet, which is in the housing of the lens. Basically, depending on how much current we drive to the lens, we can decide precisely how much to pull or push on the membrane. And in a few milliseconds, very accurately, we can determine the radius of curvature of the membrane. And this will determine the focal power and exactly the working distance at which we're focusing. And some of the key properties and unique selling points of our liquid lenses is that we have the capability of manufacturing liquid lenses with very different clear apertures from very small, so 2 to 3 millimeters, all the way to 50 millimeters. And this enables us to address applications that are very different from each other. The fast response of the liquid lens, depending on the clear aperture, is always between 3 to 10 milliseconds. And importantly, the optical liquid has a very low dispersion, meaning that the Abbe number is very high. So if you're working in the visible range from red to blue, but also in the shortwave infrared, the index of refraction of our lens will not change much, and this is very crucial. And since the actuation that we use is very elastic, there's no friction, we have proven that we can basically actuate these lenses for several billions of cycles without any detrimental effect to the optical performance. And this is obviously key in very high duty cycle applications in industrial environments. And last but not least, in a recent white paper which we have published on our website, we have proved that these lenses can be accurate, stable, and repeatable up to 10 millidiopters, and maybe I can explain later what this means. And this is obviously very important in applications such as high magnification inspection or metrology. Obviously, we manufacture focus tunable lenses, but what we can now offer is a wide range of what we call electrical lens modules, which basically means that the customers have access to a solution which is plug and play. So as you can see, we have a wide range of, let me turn on the pointer here. We have a wide range of entocentric and telecentric lenses, which come directly with our liquid lens integrated. And as you can see, depending on the specific liquid lens models that are integrated in these solutions, we can have S-mount modules for embedded vision, for example, or board level cameras. We have C-mount and even TFL mount for high resolution situations that are more suited for, let's say, microscopy or industrial applications that really need the high resolution. And as you can see, we support sensor sizes which range from 1 over 2.5 all the way to 2 inches. And even when it comes to the focal length and magnification, we really have a wide range of solutions which basically enable virtually every use case to find a compatible lens from our side. And it is worth mentioning that obviously Optotune manufactures the liquid lenses, that's our expertise. And to produce this electrical lens modules, we partner with a variety of players in the machine vision industry. And you might recognize some of these names. And this ensures that you really get high quality, high resolution for each and every of our liquid lens modules. It is also worth taking a couple of minutes to talk about lens controllers, because the liquid lens is obviously the protagonist in in the story, but the other part of, let's say, the game is the controller, because you need electrical current to get the best, to make the liquid lens work, and you need the current controller to be the right for your specific application. And as you can see, Optotune offers a range of different current controllers, ranging from a single channel USB controller, passing from a 4-channel industrial controller, all the way to an embedded controller, which we released last year or the year before. And this means that no matter what the application is, no matter what interface the customer might want to use, be it USB, Ethernet, analog, or serial, we will find the right solution for the customer. And we even support software integration, as you can see on the bottom slide, with SDKs in Python and C Sharp. And what I want to mention is a novelty which we recently added to our portfolio, which is the possibility of using our embedded controller to basically focus directly from a camera using the Genicam interface. So instead of having two interfaces, one for the liquid lens and one for the camera, now selected camera companies, which I will show in the next slide, basically upgraded their firmware in a way that the camera can talk to the controller and directly focus. And this is very attractive for customers that might want a more embedded or simple solution in their systems. So as you can see, this is a schematic that further exemplifies or explains how this works. You will have your camera, which using serial interface, so U or I square C, will talk to our controller and basically focus directly. And at the moment, amongst companies that have successfully done this, we can find Allied Vision, Basler, and even Opto Engineering, which made even a further step because they basically integrated a current controller on their camera, which means that they can control our liquid lenses without needing our embedded controller. And to finish my presentation, I would like to provide you with some real use cases coming from the market, from the industry, where there are some problems and these problems can be addressed and solved using our liquid lenses. So in high throughput industrial assembly or inspection, um, using our fixed focal lens modules, you might have situations where you need to inspect bottles in food and beverage, pipes or profiles, or even in smart desks, where basically an operator assembles something and the working distance of the object changes over time. And in these situations, the problems might be that for the same production line, you have different products which have different heights, or maybe that there's and not enough time to refocus using a linear motor. It might be too inconvenient for human operators to manually refocus every time, and it might be too expensive to integrate multiple cameras in the same system. And any of these problems are addressed and solved using our liquid lens modules, because we offer millisecond fast refocusing from working distances as short as 150 millimeters all the way to infinity. And obviously, there's no human operator needed. There's no added vibrations coming from the liquid lens. And we offer, as I previously described, focal lengths ranging from 6 to 80 millimeter, meaning that no matter what working distance range needs to be addressed, what field of view need to be addressed, we will find the right solution for the customer, even supporting pixel sizes as small as 2.4 microns. And last but not least, similar situations present themselves when it comes to high magnification inspection that need telecentric optics. So as you can see here, we have situations such as semiconductor inspection and bonding, electronic pick and place, or even pharma with high magnification microscopy for cell counting. And in these situations, the problems might be that obviously the higher the magnification, the shorter the depth of field, as Andreas from Vision and Control explained very well in the first presentation. In the semiconductor world, as you can imagine, time equals money, and conventional focusing takes too long. And in microscopy or cell counting, the higher the magnification, the smaller the volume you can inspect. And again, our telecentric lens modules basically solve these problems by providing a depth of field which can be increased up to 100 times in a few milliseconds. The magnification change is very low and predictable, and the repeatability is between 10 to 20 millidiopters, meaning that this is well within the depth of field of the telecentric optics. Again, no vibrations and a very wide range of magnifications from 0.1x all the way to 10x, addressing a wide range of different applications. And with this, I would like to thank you a lot for